come with the equation of a change in atom in the first level also. That could be written as the first level could be populated by means of atoms presented in the second level. This is because of when there are different way the atoms present in the second level may come to the first level. So, the accumulation of atom could be done by means of emissions. So, that is can be Bi(N2). And then because of a pumping there are a depopulation of atoms from the first level. So, that could be signed as a minus. So, then accumulation of atom in the first level is a plus Bi(N2) and minus Bi(N1), and as well as by means of a spontaneous emission the atom can be populated in the first level by means of a second level. So, there is that could be written as minus An2. So, like we can write the rate of change of number of atoms presented in the second level can be written as Bi(N1) minus N2 minus An2. Likewise, I can write the equation for dN1 by dt, the accumulation of atom or a change in number of atoms present in the first level, or these are the categories Bi(N2) minus Bi(N1) plus An2. So, then after making these concepts, and then we will derive the equation. The change in number of atoms equation is nothing but the delta n, which is equal to n by 1 plus I by divided by I saturated. Here delta n is nothing but the N2 minus N1. Here I saturation is the intensity, and this value is always positive. Because of this positive, it is inversion is impossible in a two level system. That means accumulation of atom always in the lower level is higher than the excited level. So, there is no stimulated emission is possible in the two level system. So, only let us come to the point of a rate equation for a three level system. So, three level system which consists of three levels: level 1, level 2, level 3. Number of atoms present in the level 1 is N1, number of atoms presented in the level 2 is N2, number of atoms presented in the level 3 is N3. So, if an atomic assembly is exposed for light energy, the total number of atoms presented in the atomic energy can be written as N is equal to N1 plus N2 plus N3. Now, we shall write the rate equation from the third level onwards. We have to make very careful how these equations are written. I will explain about in detail about the third level, and let us come to the point of population of second level and the first level. The third level rate of change of atoms in the third level. That means rate of change means there are two ways. The third level may be populated or it may be depopulated. Populated activity is considered as a positive, depopulated activity is considered as a negative. So, when we are coming to the point d, the rate of change of atoms in the third level dN3 by dt. So, third level could be populated by means of pumping energy given to the system and number of atoms presented in the envelope. So, this is the positive. So, then the parameter first WPN1, this parameter will accumulate the atom in the third level. Next, sometimes there are a hefty number of atoms may be presented in the third level. Whenever we are giving pumping energy, because of some triggering, the atoms presented in the third level may come to the first level. There are chances, first level or second level, there are chances. So, this activity may be considered as a decay of atom or a depopulation of a third level. So, that could be written as, so depopulation means I have to put a negative sign. So, it is not it is negative sign means there is a reduction of atoms presented in the third level, that could be put in a minus sign. That is now I can write the WP minus WPN3 minus WPN3. There are possibilities of atom may come from the higher level to the lower level. because of this there is a depopulation in the third level. So, population may be affected by means of this process. And another one process, there is a accumulation of atoms because of a lifetime of a third level. Suppose the lifetime of a third level may be higher, it can populate more number of atoms. So, that could be written as a N3 D32, where D3 is a lifetime of atom in level 3. If the lifetime of atoms in the third level is more, there is accumulation of atoms or more. So, I can write dN3 by dt, it can be written as a Wp N1 Wp minus Wp N3 plus N3 D32. So, first parameter Wp N1 is accumulation, minus Wp N3 is a depopulation, plus N3 D32 is a population. Okay. Let me come to the point of rate equation for level 2. Rate equation for level 2, now we can discuss about the second level accumulation of atom or a change in number of atoms in the second level. So, what are the probabilities? The first one is it could be populated by means of a lasing energy. Lasing energy means WL. There may be if you are giving an energy, atoms presented in the higher level, third level may populate the first level, or pumping energy, lasing energy WL N1. When you are giving a pumping energy to the system, after absorbing energy, the atoms can move to the second level, that is a WL N1. So, atoms present in the first level atoms can go to the second level. This is one possibility. After then, there are a decay of atoms in the second level by means of spontaneously, which is coming down from the second level to the first level, that is we can say WL N2 after completion of its lifetime. That is a depopulation, then I will put a minus sign. Another one, if the lifetime of atoms presented in the or a life relaxation time, that is we can say D32 is nothing but the relaxation time is more for a second level, there is accumulation of atom from the third level to the second level. So, this again it is a positive. So, I can say that is a plus N3 D32, this add the atoms in the second level, and then after completing the lifetime of atoms presented in the second level may come to the first level. So, then this is a decay of atom. So, that put is a minus N2 by D21. So, we can write dN2 by dt, it can be written as a WL N1, this is accumulation of atom, minus WL N2, this is telling the decay of atom, plus N3 by D32, this is accumulation of atom in the second level, minus N2 D21, this is the decay of atom in the second level. So, then likewise I can come to the point of rate equation for level 1. How shall I write the rate equation for level 1? So, here there are so many parameters. The change in atoms presented in the lower change in atoms presented in the lower level, that is the ground level, may be affected by means of various parameters. It may affect by means of pumping energy, it may affect by means of a lasing energy, it may affect by means of a lifetime atom presented in the second level, all these things. So, then there are different activities will come or are exposed to the first level. So, that would be written as with the same methodology I can write this dN1 by dt is a Wp N3 positive, which may accumulate the first level, Wp minus Wp N1 which will reduce the energy, and then plus W1 N2 which will increase the energy, and again minus WL N1 which will decrease the energy. So, there are so many parameters. So, we can write this dN1 by dt is equal to Wp N3 minus N1 plus WL N2 minus N1 plus N2 D21. Wp is for a pumping energy, WL for a lasing energy. So, then with this background we can write the another equation, that is dN1 by dt plus dN2 by dt plus dN3 by dt is equal to 0. This is obvious because N1, the total number of atoms presented in the assembly is a constant, that means N is equal to N1 plus N2 plus N3. So, if you are differentiating with respect to time, automatically the constant becomes 0. So, I can write dN1 by dt plus dN2 by dt plus dn3 by dt is equal to 0. So, by using this concept, that is for we can say the steady state concept, we will find the number of atoms actually accumulated in the second level, number of atoms actually accumulated in the third level is written analytically by means of this equation. N2 is equal to WL plus D32 WP divided by WP plus D32 N1 divided by WL plus D21. This is giving, this expression is giving the number of atoms present in the second level, as well as this expression N3 is giving the number of atoms present in the third level. These two atoms, number of atoms present in the two levels are root cause for the stimulated emission of radiation or laser action. So, then the ratio of change in number of atoms in the N2 minus N1 with the total number of atoms, if it is positive, there is no laser action. If it is negative, that will lead a laser action. This is the concept. So, this we will come to the condition N2 minus N1 divided by N is so much. This is the condition for obtaining a population inversion between level 2 and 1. So, for N2 minus N1 to be positive, necessary condition is the relaxation of a D32 greater than should be a D21. That is, a relaxation time of a third to second level should be greater than the relaxation time of a second to first level. If this condition is achieved, automatically there is a population inversion will be taking place. That means the lasing level is more populated than a ground level. Once the more population is taking place, automatically if we are giving even a single photon, that will trigger the assembly, it will give out with the laser radiation. This is the methodology for writing the laser equation. I have given a very simple concept how to write a laser rate equation for a third level system. So, this is my today's topic. So, now there are different types of lasers we can see in our market, that is these are all only after this type of a discussion which are happened for nearly 45 years. Then we could able to obtain the first laser as a ruby laser. After then there are many number of lasers were invented. One is a solid state laser and semiconductor laser, dye laser and a gas laser, excimer laser. Each and every lasers are having its own unique properties. So, this is about my lecture. Thank you.